Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best engineering college in the northern India and the fastest and the most developing college of the country. It has a variety of courses to choose from BTech, BBA, BCA to MBA, Architecture and Law with coming up recently. It provides best quality education at best prices. This is one of the finest college in the industry. It provides 100% job placement and job assistance to its student. The quality of education is the focus. The teachers are very highly research oriented and it is the finest college that you can get admitted yourself to. The subject we are looking here is mathematics sorry Mathematical Foundations of Computer Science BCA 108. This is a BCA second semester subject. The topic we shall be taking on over here is trees, that is minimum spanning trees and minimum distance trees. Trees. Okay. Now what is a tree? See, a tree is a non-linear data structure, right? So it means it does not proceed in a line, but it can proceed in a non-linear way compared to arrays, linked lists, stacks and queues, which were linear data structure. So tree is non-linear. A tree can be empty with no nodes, or a tree is a structure. Acha, what is the other non-linear structure we studied previous to trees? Graphs, right? So graph, and after graph we have trees, which is a non-linear data structure. A tree can be empty with no nodes, or a tree is a structure consisting of one node called the root and the zero or one or more subtrees. So A is the root tree, B and C are the subtrees of the A, and these are the nodes. So A happens to be the parent of B and C, B happens to be parent of D, E, F and G are the child of C, right? So and the last nodes are the leaf nodes, that is which do not have any child. So level is defined by your root is at level 0, then your next is a level 1, 2, 3. So this is how you do the nomenclature in a tree. So there are these important terms that you need to know when you are dealing with tree. See, path. What's a path? A path refers to the sequence of nodes along the edges of tree. So along whatever edges that you are proceeding, so that path is a path. The sequence of the nodes. Root, that is the node at the top of the tree, is called the node. There is only one root per tree and one path from the root node to any node. Parent, any node except the root node that has one edge upward to a node called parent. What is parent? That has one edge upward. Child, the node below a given node connected by its edge downward is called its child node. What is the leaf? The node which does not have any child node is called the leaf node. Subtree. Subtree represents the descendants of a node. Visiting. Visiting refers to checking the value of a node when control is on the node. Traversing. Traversing means passing through nodes in a specific order. Levels. Level of a node represent the generation of a node. If the root node is at level 0, then its next child level is at level 1. Its grandchild is at level 2 and so on. So this is how you define levels. Keys. Key represent the value of a node based on which the search operation is to be carried out for the node. So that is the value the node holds is the key. So A was the key, right? So now we have minimum distance trees. You also tell the minimum spanning trees. See, the cost of the spanning tree is the sum of the weight of all the edges in the tree, right? So you see how what are all the edges, and that counts to be the weight on them, that happens to be the spanning tree. The minimum spanning tree is the spanning tree where the cost is minimum among all the spanning trees. So all the nodes that you're having, and the one that provides the minimum cost is the minimum spanning tree. There can be many spanning trees, like see, any if there are two ways and that the lowest weight arouses answer is 7, and there are two weight that are giving it, so there it can have two minimum spanning trees, right? So minimum spanning tree has direct application in the design of networks. It is used in algorithm approximating the traveling salesman problem, multi-terminal minimum cut problem, minimum cost weighted perfect matching, and other application include cluster analysis, handwritten recognition and image segmentation, right? So this is a graph, that's an undirected graph. So we have four nodes, and see this is with weights 1, 4, 3, 2, and 5. Now this is a spanning tree. From here, if I start at the leftmost top node, 4, then 5, then 2. So this is the total cost is 4 plus 5 is 9, 9 plus 2 is 11. Now this is the minimum. So wherein this 1 is joined, 2 is joined. So this is 1 and 2 is 3, 3 and 4 is 7. So 7 happens to the minimum. See, if I will join 3 in here, it is not a minimum spanning tree, since I've left this one node, and also it cannot form a cycle, right? So tree never forms a cycle. You just remember this. There are two famous algorithms for finding the minimum spanning tree, that is Kruskal's and algorithm and Prim's algorithm. Kruskal algorithm builds the spanning tree by adding edges one by one into a growing spanning tree. How you do? You add one edge at a time, one by one, by growing a spanning tree. Kruskal's algorithm follows greedy approach, as in each iteration it finds an edge which has at least weight and add it to the growing spanning tree. So how you will do? You will take one edge, right, and edge by edge you will build the spanning tree, right? So this is greedy. See, sort the graph edges with respect to their weight. So you start with a minimum, adding edges to the MST from that smallest weight until edge of the largest weight, right? And only add edges which do not form a cycle, right? Edges which connect only disconnected component, that is there. So you cannot join anyone which is already connected. So the time complexity is order of E log V, wherein V is the vertex and E is the edges. So this is the overall kind of time cross complexity in Kruskal's. See, we can say with example, the minimum, see, out of this first figure 1 7 5 3 2 4 6, which is the minimum 1, so I took 1. Then which is the minimum after I've joined 1, this is 2, so this is 2, right? After 2 it is 3 3, right? So this is joined. Now only G is left, so I see how to join this. Why I can take 5 or 6 or 7. So 5 is smaller than this thing, so this happens to be my minimum spanning tree. I cannot form a cycle, right? So that is there. You should keep this thing always in mind. Okay. So Prim also uses greedy approach to find the minimum spanning tree. In Prim's algorithm, we grow the spanning tree from a starting position. So you take a position and you start from there. Like so, unlike an edge in Kruskal's, we add vertex to the growing spanning tree in Prim's algorithm. Maintain two disjoint sets of vertices, one containing vertices that are in the growing spanning tree and other that are not in the growing spanning tree. Select the cheapest vertex that is connected to the growing spanning tree and is connected in the growing spanning tree, and add it into the growing spanning tree. So you took one, then you take the next, and then you keep on adding it. This can be done using priority queues. Insert the vertices that are connected to growing spanning tree, right? So you always need to see that you have maintained the connections. So you check for cycles, the like you cannot have a cycle. And what is the complexity? That is V plus E log V, right? So you start with vertex and then you join the edges, that is why it is V log E, and then you see that you have joined in the vertex, so that is why V plus E log V. So because each vertex inserted in the priority queue only once, and insertion in priority queue takes logarithmic time, so you're doing it q times, right? See, I take the minimum, that is 1, so I put this in joint. Then I from 1 I see that 2 is the minimum, then I join this 2. Then I see 3 is the minimum, but it forms a cycle, so I delete it. Then out of this I see which is the next connected thing I can take. So 2 1 I take 4, right? So this is my starting vertex and I move in this. So this is how Prim's algorithm works, right? You cannot find any disconnected component over here in this, where in edges you can see they were disconnected components, right? So this is all about spanning trees. The question can be, what is a tree, what are minimum spanning trees? It can ask you Kruskal's algorithm, it can ask you Prim's algorithm. I hope this is clear. It's very very simple, and you I hope you are clear with both of the algorithm and the difference between them. Also the way they're working is, you actually both of them are giving you minimum spanning trees, but there are two ways of doing it. So Kruskal is one way and Prim's in one way. So you in by both the ways you're finding MST, that is minimum spanning tree. But this minimum spanning tree, is the difference is in the working. So I hope you understood it. Thank you so much. Have a great day.